Hello dear students, once again welcome back to our channel. In this video we are continuing exercise 8.4 question number 5. We have already completed 5 sub questions comes under 5th question. We have 5 more sub questions, okay, and we can start with the 6th problem. Okay, so here prove the following identities. Okay, and here we have the identity root of 1 plus sin a divided by 1 minus sin a equal to ck plus tan a. As I told, this is an identity. We are going to prove this, okay, by taking the LHS. We are going to solve the LHS part, okay, and we are showing that is equal to RHS. That is a procedure. Okay, so we can start with this LHS, that is root of 1 plus sin a divided by 1 minus sin a. We are going to solve this. See, in this type of problem, we are following a common procedure, and that means we have to multiply the fraction which comes under the square root. See here, 1 plus sin a divided by 1 minus sin a, both are under square root. Okay, so multiply this fraction, okay, by taking, if the denominator, the terms are connected by minus, you have to take plus, that is 1 plus sin a divided by 1 plus sin a, that is equivalent fraction. We are multiplying this fraction, that is the fraction that is 1 plus sin a divided by 1 minus sin a. This should be multiplied with, since 1 minus sin a is there, to multiply both the numerator and denominator with 1 plus sin a. If here comes 1 plus sin a comes, you have to multiply with 1 minus sin a divided by 1 minus sin. That is the procedure. Okay, that you should keep in your mind, children. So multiply with 1 plus sin a divided by 1 plus sin a. Okay, still both are in the under square root. Now let us see, children, how this can be multiplied. Okay, multiply the numerator and the denominator. Okay, so which means this is equal to, this can be simplified, 1 plus sin a into 1 plus sin a is 1 plus sin a whole square, a plus b into a plus b whole square. So 1 plus, both are plus, so 1 plus sin a, we multiply the numerators, okay, that is 1 plus sin a whole square divided by, yes, here 1 minus sin a and the second factor is 1 plus sin a plus b into a minus b, that identity, that is a square minus b square. Okay, that is 1 minus sin a into 1 plus sin a, that is a minus b into a plus b, isn't it? So that is a plus b into a minus b, this is equal to a square minus b square. Here a is 1. Okay, 1 square is 1 itself, minus sin a whole square, that is sin square a. Sin square a. Is it okay? Yes. Now in the next step, what can be done? See, if root of a by b, a fraction comes under the square root, you can split and give the square root for both the numerator and the denominator, that is root a by root b. Okay. Yes, that idea we can apply. So for that we are we are splitting this, that is root of 1 plus sin a whole square divided by root of 1 minus sin square a. I hope how we got this step is clear, children. We just split that square root for numerator and denominator. Okay. Now see, children, root of 1 plus sin a whole square. Okay, that is the term numerator having the square, okay, and that comes under the square root. That means we know that root of x whole square, this is equal to x itself. Okay, that is square root and this square get cancelled. Square root of x is x raised to 1 by 2. Okay, and square get cancelled, that means x. The same way, this square root and square get cancelled. Okay, that means in the numerator, it reduced in the form 1 plus sin a divided by. See, what is 1 minus sin square a? Can we apply the identity? Which is the identity? First identity, you can write that is 1 minus sine square A is cos square A. Understood? That means instead of this 1 minus sine square A, under the square root, you can write this is equal to cos square A. Next step. Okay, so this square root and this cos square, that square get cancelled. Okay, which means after taking this cos square from the square root, it will reduce in the form cos A only. Hope that it is clear. That means square root of cos square A. Actually, cos square A is cos A square, whole square. So this square and square root get cancelled. So cos A. That is free from the square root. So now we have 1 plus sin A divided by cos A. But see the RHS, CK plus tan A. We should reach this LHS into CK plus tan A. Okay, for that here 1 plus sin, 2 terms in the numerator and only 1 term in the denominator. Okay, see that means if we have x plus y divided by x, what can be done? We have to split the denominator to both the terms in the numerator. That means x by x plus y by x. We are doing this manner. So 1 by this is equal to 1 by cos A plus, what is the second term? Sin A by cos A. Okay, second term is sin A. So you have to give that cos A to the second term also. It is clear. So 1 plus sin A by cos A, now it is in the form 1 plus cos A plus sin A by cos A. What is 1 by cos A? Reciprocal relation, and this is equal to sec A plus tan A. Sin A by cos A, quotient relation is tan A. That means we have taken the LHS and we can easily reach into this RHS. That means we have proved the identity, that is root of 1 plus sin A divided by 1 minus sin A equal to CK plus tan A. Now the seventh question, that is sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta equal to tan theta. This is identity. Okay, we can prove this by taking the LHS. We are going to solve that and we can easily show that that is equal to tan theta. Okay, and for that the LHS, that is sin theta minus 2 sin cube theta. That means we have 2 terms in the numerator and also 2 terms in the denominator. 2 cos cube minus cos theta. Okay, see from these 2 terms in the numerator, the sin theta minus 2 sin cube theta. What is sin cube theta, children? Sin theta into sin theta into sin theta. Okay, and here already 1 sin theta is there. So I am going to take sin theta from the numerator. 2 terms. I am taking sin theta from the numerator. Sin theta into, what will be there after taking sin theta? There will be sin theta by sin theta, that is 1 remaining, minus, so 2 is there, 2, so sin square theta will be there, sin theta into sin theta into sin theta. So 1 sin theta I have taken outside, so sin theta into sin theta. So we will have sin square theta comes in the second term. Okay, divided by, the same way, see the denominator, it has also 2 terms in cos cube theta, here cos theta. Okay, so I am taking cos theta common from the 2 terms. So cos theta into, here cos cube theta means cos theta into cos theta into cos theta. So cos square theta is there and also 2. Okay, so 2 cos square theta minus 1. After taking cos theta, there will be 1 alone in the second term. Okay, see what we have to prove, children, this should be equal to tan theta. That means here already we have sin theta by cos theta. That is equal to tan theta. By quotient relation, sin theta by cos theta is tan theta. But so what is our aim? Our aim is now to show that this fact, the 1 minus 2 sin square theta divided by 2 cos square theta minus 1 equal to 1. If those get cancelled, you can easily write this is equal to tan theta. Okay, so for that I am not making any change over this sin theta in the numerator and cos theta in the denominator. We can work on the second fact, that is 1 minus 2 sin square theta. Okay, and for that sin theta, no change children, and for this 1, okay, here we have the expression in sin square and cos square. So I am going to substitute that 1 with respect to the first identity, because sin square theta plus cos square theta is 1. So I am going to write, instead of 1, an equivalent expression in identity, and that is sin square theta plus cos square theta. This is the first identity. And which is the second term? 2 sin square theta is there. Okay, I am making any change for the second term, that is 2 sin square theta comes next. Okay, divided by, in the same way in the denominator cos theta, I am making any change because we need these 2. Okay, because that is the thing, that is if you cancel this and other factors, you can write tan theta. So I am making any change for these 2. And the same way, this 2 cos square theta I am making any change, but in 1, the same identity, that is sin square theta plus cos square theta, isn't it? So since we have minus outside and 2 terms in the bracket, we have to give this negative sign, multiply both terms with the minus outside. So minus sin square theta minus into plus become minus. That step is okay children. So I am going to make that step over here and open the bracket. Okay, then plus and minus become minus. Okay, so we have 3 terms here after sin theta in the numerator. Okay, second factor, sin square theta, cos square theta minus 2 sin square theta. Okay, we can simplify. We have 2 terms in sin square theta, that is here is first term sin square theta. Here we have minus 2 sin square theta. So sin square theta minus 2 sin square theta. See children, sin square theta minus 2 sin square theta. What is this? That is, this is sin square theta. You can treat that in like terms. Okay. So x square minus 2x square in place. So you can think of this expression x. How can we solve this? Being the variables are same, you can just subtract the coefficient 1 minus 2, that is minus 1. If 1 we are not writing 1, so minus x square. Okay, so the same idea we are applying over here, that is sin square theta minus 2 sin square theta. You can consider the coefficient of sin square as 1. So 1 minus 2 is minus 1. So sin square minus sin square theta. Okay, so this reduced in the form, this together minus sin square theta, here plus cos square theta. Okay, that means here we have cos square theta minus sin square theta. Understood children how this comes? I have written this positive first, the positive x cos square theta, and here minus sin square theta. How this minus sin square theta comes, clear? Okay. In the same way I am making any change for the cos theta, and here the denominator, this factor can be simplified. Here we have 2 terms in cos square theta, 2 cos square theta, here minus cos square theta, that is 2 minus 1, that is 1, that is positive cos square theta minus sin square theta. So this, when we add this 2 cos square theta and minus cos square theta children, we have cos square theta and this minus sin square theta. Okay, this is the change what I am going to write over in the next step. Okay, so this is equal to sin theta into, in the second factor here the bracket reduced in the form cos square theta minus sin square theta. Clear children? Cos square theta minus sin square theta divided by here cos theta, and here also this 2 cos square theta, cos square minus cos square theta is cos square theta and minus sin square theta, cos square theta minus sin square theta. Now you look into this new expression, that is sin theta into cos square theta minus sin square theta. Here also cos theta into cos square theta minus sin square theta, which means these two can be cancelled. Okay, so the things which we have, the remaining is sin theta by cos theta is tan theta. See the RHS? That means after taking this LHS, after simplification, we have proved that this is equal to tan theta and that is equal to the RHS. That means LHS after solving, we could easily show that that is equal to RHS. This is one of the very important problem of this exercise. Now we have the 8th question, sin A plus cosec A whole square plus cos A plus sec A whole square equal to 7 plus tan square A plus cot square A. Okay, how this can be solved, children? Even if this is very lengthy identity, this can be easily solved. Okay, by as usual by taking the LHS. Okay, and in LHS, sin A plus cosec A whole square. Here cos A plus sec A whole square. Okay, in both the terms we are going to apply this identity A plus B whole square. A plus, they are connected by plus, so A plus B whole square. Okay, even if you can think of the sec as 1 by cos A and here also cosec A 1 by sin A. Okay, that method we are not applying here. Okay, here we are applying this identity. We are using the identity that is sin A plus cosec A whole square, A plus B whole square. That is A plus B whole square is A square plus B square plus 2AB, right? So in place of A sin A cosec A. So this LHS becomes sin square A square sin square A plus B square cosec square A plus A 2AB, 2 into A is sin A and B is cosec A. Okay, plus the same identity we are going to apply the second term cos A plus sec A whole square, that is cos square A plus sec square A plus 2AB, 2 cos A into sec A. Okay, see children, what we have to show? This is equal to 7 tan square plus cot square. That means we have to reduce this sin cos, okay, that is in terms of tan square and a cot square. Okay, and for that, see after writing this identity, expanding the using the identity, you can see, you look into the terms, here sin square A. Okay, here you can see cos square A. Sin square A plus cos square A. See children, from this expanded form, you can take the sin square A plus cos square A by identity 1 that can be written in the form 1. That is sin square A plus cos square is 1 because we need a constant 7 there, okay, in the RHS. So this together you can write this is equal to 1. Sin square A plus cos square A is 1. 1 plus, and we have cosec square A, here we have sec square A. Okay, I am making any change for that, that is cosec square I am keeping as it is. Okay, and here see children, 2 sin A into cosec A. Can we apply? See, we know that in the reciprocal relation, the product of a ratio with its reciprocal is 1. Or here sin A equal to 1 by cosec A, right? Sin A is 1 by cosec A or cosec A equal to 1 by sin A. So if you take this into LHS, that is sin A into cosec A is 1. Or this is a result, a ratio with its reciprocal, product of a ratio with its reciprocal is 1. So here since we have 2 into sin A into cosec A, this is reduced into 1. So that means plus this plus 2 into 1, then plus this cos square we already have taken and we together we got 1 using the identity, first identity. Here sec square A, I am writing c square without any change, plus here also see children 2 cos A. See cos A and sec A, reciprocal relation. The reciprocal of cos A is sec. So the product of a ratio with its reciprocal is 1. Or see children, here cos A is 1 by sec A. that is ck into cos A or cos A into ck is 1, and here we have 2, so 2 into 1, that is 2 itself. Okay, so we are going to further simplify this. Here the constants 1, here 2 into 2, 2, here also 2, so 2, that is 4 and plus 1, 5 plus, and the terms remaining are cosec square A and sec square A. But see the RHS, here 7 plus tan square A plus cot square A. That means we have to substitute for cosec square A and sec square A. These two ratios are not there. Okay, so how this can be solved, children? Using further we can apply the identity. Which is identity? Okay, here the sec square A, from the third identity. What is the third identity, children? That is cosec square A minus cot square A equal to 1. Okay, from this can you substitute for cosec square A as, if you take that minus cot square A into RHS, so 1 plus cot square A. Okay, so that identity we are applying over here. We are going to substitute cosec square as 1 plus cot square A using the identity. Okay, so equivalent expression for cosec square in terms of cot square, and at the same time we need cot square in the RHS part. Okay, we have to, after solving this LHS, we need that term. Then only we can write LHS equal to RHS. Okay, so cosec square is 1 plus cot square A. The same as sec square. Sec square from the second identity, we have the identity. What is identity, children? Second identity, by equating RHS into 1, we have sec square A minus tan square A equal to 1. But we need the substitution for sec square. So from this you can write sec square equal to 1 plus tan square A. So I am going to substitute sec square as 1 plus tan square A. Okay. So plus 1 plus tan square A. 1 plus tan square A. Again we can simplify. We have constants can be added together. 5 plus 1 6 and plus 1 7, and we have cot square A plus tan square A. Okay, we have taken this LHS and we applied this identity A plus B whole square. Okay, and the two identities we reached into the 7 plus cot square A plus tan square A, and that we have seen that is equal to RHS of the given identity, which means LHS, this is equal to the RHS. Okay. Now the 9th question. Here cosec A minus sin A into sec A minus cos A equal to 1 by tan A plus cot A. Okay, so as usual we can take the LHS and we can solve. Okay, that is, here we have cosec A minus sin A. Okay, see, cosec A can be written in the form 1 by sin A. We can apply that reciprocal relation, that is cosec A minus sin A. We are writing the LHS part first, and we are going to substitute using the substitution using the reciprocal relation. Okay, so cosec, in place of cosec A you can write 1 by sin A minus sin A, make any change for the second term, into, okay, sec A. Give substitution for only one ratio, that is sec A, since it is 1 by cos A, and second term is cos A itself. Okay, so I just taken the reciprocal of cosec A and sec A by keeping sin and cos A as it is. We can simplify this first bracket, that is 1 by sin A minus sin A. Okay, you can treat this as sin A by 1 by cross multiplication. 1 into 1, 1 minus sin A into sin A, sin square A, divided by product of the denominator. Sin A into 1 is sin A, into, here into, same way we can write here the denominator as 1 for the cos A second term. So cross multiplication, 1 ones are 1 minus cos A into cos A, cos square A divided by Cos A into 1 is cos A. Now I think almost you are getting the idea how this next step can be written. Okay, so 1 minus sin square A by identity 1, that is sin square A plus cos square A equal to 1. So 1 minus sin square A is cos square A, isn't it? That is cos square A divided by sin A, okay, into, here into, okay, here also into, okay, 1 minus cos square, the same identity. Which is identity, children? That is, we have first identity sin square, both case we are using the same identity, that is sin square A plus cos square A equal to 1. So if you need sin square A, you can take cos square. Sin square can be expressed in terms of cos square A, or cos square A equal to 1 minus sin square A. Okay, so here we have 1 minus sin square A, and we know that is 1 minus sin square A is cos square A. Here in the second case, 1 minus cos square A can be replaced as, see, 1 minus cos square A is sin square A. Okay, so that is a change in the next step. That is 1 minus cos square A is sin square A using the first identity divided by cos A. Step is okay? Now see, as usual, here you can see that cos square A and cos A, they are connected by into, so that you can reduce. So cos square A is cos A into cos A, so square get cancelled, 1 cos A is remaining. The same way from the denominator sin A, here sin square A, so get cancelled. So 1 cos A and we have 1 sin A. We have in the final step cos A and sin A. Okay, after simplification, we have reached into cos A into sin A. But here what is in the RHS? That is 1 divided by tan A plus cot A. Okay, in the beginning I told some cases we have to separately taken the LHS and solve. And we can finally show that the new LHS equal to the new RHS. Okay, that idea we can apply over here, so that I am taking the RHS of this identity and I am going to solve for that 1 divided by tan A plus cot A. See children, what is our aim? We have to reduce this into this cos A into sin A. Okay, that means we have to give the substitution for tan A as well as this cot A in terms of sin and cos A. And we know that is tan A is sin A by cos A, okay, quotient relation, and cot A is cos A divided by sin A, okay, and in the denominator 2 fractions, okay, so we can cross multiply because they are connected under plus sign. If it is into, you could have cancelled, but being they are connected by plus or minus, you have to cross multiply. So sin A into sin A, sin square A plus cos A into cos A, cos square A whole divided by the product of the denominators cos A into sin A. Isn't it? What can be the next step, children? See this, the denominator of this fraction, that means you have 1 divided by, what is sin square A plus cos square A, children? Identity 1, sin square A plus cos square A is 1. So 1 divided by 1 by cos A sin A. 1 divided by, see, what is 1 by x by y? That is reciprocal, that is y by x. The same way, 1 by cos A minus sin A, cos A into sin A, take the reciprocal, that means you will have cos A sin A. Okay, when you take the reciprocal of 1 by means you have to take the reciprocal of the denominator, then multiply. The reciprocal of 1 by cos A sin A is cos A sin A by 1. So that will come to the numerator. Okay, so we have reached into cos A sin A. By taking the RHS, we have this RHS is cos A sin A, and the LHS after solving we have seen that is also cos A sin A. So what you can write? LHS equal to RHS. Okay, so this is all about the 9th problem. Now the last question, and the question is 1 plus tan square A divided by 1 by cot square A equal to 1 minus tan A by 1 minus cot A whole square, again equal to tan square A. Okay, we are following a different approach to get into this answer. Okay, for that I am taking, see children, here they are connected by equal to sign. Okay, and in order to get this answer, in order to show that this result, okay, this is the way, that is I am taking first and third. Okay, that means, and I am showing that 1 equal to 3. See, 1 equal to, if I can show that 1 equal to 3, and also second case 2 equal to 3, which means 1 equal to 3, 2 equal to 3 means 1 equal to 2 equal to 3, right? This is the method we are applying over here, okay, in order to show this result. Okay, and for that I am taking 1 plus tan square A divided by 1 plus cot square A equal to tan square A. Okay, and you can treat this as LHS and RHS, and I am going to solve this LHS part. Okay, and what is 1 plus tan square A? By you can use identity, that is sec square A, and this is equal to 1 plus cot square A is using the identity 3, that is equal to cosec square, and you can simplify and you can easily get into tan square A. Or those who want to apply the reciprocal relation, because tan square A equal to 1 by cot square A. Okay, you can give the substitution only for one, either for tan square is 1 by cot square A or cot square is 1 by tan square. Don't give reciprocal relation to both one, okay, so that you can't reach into this answer. Okay, so I am going to write the reciprocal of tan square A as 1 by cot square A by keeping the denominator without any change. Okay, so 1 plus tan square A divided by 1 plus cot square A equal to 1 plus 1 by cot square A, that is the reciprocal of tan square A is 1 by cot square A, and no change for the denominator, that is 1 plus cot square A. Now we are going to simplify, okay, being they are connected by plus cross multiplication. So this is equal to, here we can write this is equal to cot square A and 1 into 1 and the product of the denominator is cot square A. Okay, and we have in the denominator without any change 1 plus cot square A. See children, here we have A by B whole divided by C. C means C by 1. Okay, that means you have to take the reciprocal of the second fraction without making any change in the first fraction. Okay, that means in the numerator no change, that is you can write here, that is cot square A plus 1 divided by cot square A into, what is the reciprocal of this? 1 plus cot square A by 1, that is 1 by 1 plus cot square A. Okay, that is 1 by 1 plus cot square A. See children, cot square A plus 1, cot square A plus 1 get cancelled. So you will have 1 by cot square A. What is the reciprocal relation? That is tan square A. That means after taking first and third, okay, we can show that the LHS of the first case equal to the third one, RHS. That means we have proved 1 equal to 3. Now the next case, here we have this 1 minus tan A divided by 1 minus cot A whole square equal to tan square. Okay, so I am taking the LHS of that, that is second one, that is, and I am solving that 1 minus tan A divided by 1 minus cot A whole square. Okay, here I am going to substitute that is reciprocal relation tan A as 1 by cot A, just like the first case, that is 1 minus 1 by cot A divided by, no change for the denominator, okay, and whole square. The same idea, this we can cross multiply because they are connected by into. So cot A minus 1 into 1 divided by cot A, the LCM, the product of the denominators, whole divided by 1 minus cot A whole square. Understood? Okay. And in the next case, see children, here we are going to write taking the reciprocal of the second, that is here we have the a by b, here the a 1 minus cot a. Okay. So cot a minus 1 by cot a, okay, into 1 by 1 minus cot a, okay, and here we have whole square. Step is clear children? I just have taken the reciprocal of the second fraction by keeping this cot a minus 1 by cot a and multiply with its reciprocal, that is 1 by 1 minus cot a. Okay, and can we cancel cot a minus 1 and 1 minus cot a? No children, we can't. Okay, because a minus b is not equal to b minus a. You can cancel only when if this is of the form 1 minus cot a. Okay, you can change the position under the subtraction by using this result a minus b equal to minus of b minus a. Okay, if you take minus outside, then you can change the position, that is b comes in the first position. Okay, for that I am taking the minus from this, okay, that is minus of 1 minus cot a. Now you can cancel these two. It is clear children? In order to change the position under the subtraction, you have to follow this result, that is minus of b by a. So hence you can easily cancel this 1 minus cot a with 1 minus cot a, and in the bracket what you will have minus 1 by cot a whole square. That is minus, I am writing that step over here, that is this step is in the bracket, this after cancelling these two, minus 1 by cot a whole square. Okay, see children, what is this? Minus 1 whole square is 1 square, 1 square is 1 itself. So this is equal to 1 divided by, and give the square to the denominator, cot square a, that is cot a whole square is cot square a, and we know that 1 by cot by reciprocal relation, that is equal to tan square a. Okay, tan square a, and see what we have to prove. This is the RHS of the second case. That means after solving this LHS, okay, we could easily reach into this expression, that is tan square a. Okay, that means we have taken first and the third. First is equal to the third expression and second is also equal to the third, which means you can equate all the three. Okay, that is what we have done for the last question. Okay, so this is all about this exercise 8.4. So thank you children, thank you for watching and supporting my channel. Thank you all.